Welcome back. So I've got another video here to go through question number 2 from the FRQ. This one is called it's about Self Divisor. So this is a video to quickly go through this question. This question is basically a question to test whether you can manipulate a number and get the result, right? Basically you're going to be dividing a number by the digits, the different digits of the number. And so let's take a quick look at the question here. Switch over to okay. A positive integer is called a self-divisor if every decimal digit of the number is a divisor of the number. So what that means is that if you got a number 128, the numbers 1, 2, and 8 make up that number, can divide 128 evenly. So i.e. evenly meaning there's no remainder left. What that means is that we have to be using dividing and modulus. I think that would pop out to you. So let's take a look at the notepad. Okay. Open up the notepad. What it means is that we have a number like here 1, 2, 3, 4, 5. And what we want to do is take each number and divide it. So if we take 1, 2, 3, 4, 5 and we do modulus 10, we get 5 remainder. If I divide this by 10, I get 1, 2, 3, 4 and a 5 remainder. So mod 10 gives you 5, divide by 10 gives you 1, 2, 3, 4. And that's how we're going to progressively go through this. We do that again. Mod 10 gets us the 4. And that's how we can get each number. Right. In this way, we can get through the numbers and deal with them each one. Now, what happens when we get to the end? Well, we get a number that's, the final number that's left is less than 10. Sorry, less than 1. Right? Because in the end, we're going to have, after a while, we're going to have the number 1. And 1 mod 10, 1 mod 10 is 1, which is fine. And then 1 divided by 10 gives us a number that's basically 0. So less than 1. We want a number that's less than 1. Right? So even if we had 0.1, but we're not going to need 0.1. So but anyway, that's how we're going to go through it. Now, maybe when you first thought of this, you thought, well, if this was Python, I might make it into a string, and then I could like convert each one to an int. So I get convert this one to int, and then I get a 1, and I can test that one, and then I can do it again. Maybe that's how you do it, and you're thinking, oh, okay, which methods could I use in Java to do this? No, don't do that. The reason why is because this is an AP exam. Now, you may be able to do that in Java. This is an exam to test your knowledge of the basic functions. Just only use the functions that we have and the operators that we've learned. Don't need to go and dig up anything else. So this is just, it should be a very simple method. So let's go ahead and do this. And let me bring up let me make the Chrome into the side here, just so that it's easy to see. So it's asking us to write this method isSelfDivisor. So we want to test to see if the number is a self-divisor. It's a Boolean result. Let me go to Java, switch to Java. Okay, public static boolean is self-divisor. And we take a number. We don't know how big this number is, but we do know that it's a positive number. This is it says here in the precondition, it's a positive number, bigger than 0. And what we're going to do is we're going to start with finding a divisor. So we'll need to get the remainder to num left, right? So that's the number that's left after we divide, and let's start it out as the number, right, as the beginning. And then we have the test num, so the number that we're testing. And we don't know what that is yet. We won't calculate that quite yet. We'll do that later. But we just need that number. And then we also have to, and this will also be, okay, so we kind of know how many digits there are, but it might just be easier to use a while loop to do this until we get to the end. So I'm just going to use a while. I don't need to go through a for loop. While the num left is greater than 1. Or equal to, sorry. Greater than or equal to 1. Okay. Once, like I said before, once it gets less than 1, we're not interested. That's it. The last digit. So we are going to now iterate through this process and keep going. Firstly, let's set up our test num. Test num equals the number that's left modulus 10. And then we're going to test the number. If test num sorry, other way around. If number, the original number, mod test num, right? So if we divide the original number by the digit on the end, and it's not equal to 0, we know that it doesn't divide evenly, and so we can just exit the code. We found that it's not a self-divisor, and we can return false. Game over. It's over. Don't need anything else. If, on the other hand, it does divide evenly, well, we still have the rest of them to test. So we now have to set up the num left. So we have to change that number, and we'll just divide equal by 10. And then we keep going. It'll do the loop again. It'll use test num, and it will test again and again until it gets to less than 0. And then at the end, if we make it all that way without returning false, then we can just return true. And we know it does divide evenly all the way through. Okay, so that was a simple way just to get through it. Using mod, using divide in the right way. Okay, let's look to the next part. The next part of the question asks us to use this method and use it in a way that's going to be useful for generating a list or an array of those numbers. So it's saying at this point, at this number, and find this many values. Find this many values of the self-divisors. Now, don't know where they're going to occur. We just have to keep going until we find that many numbers. So it's asking us to return a list of them. So an array of them. We have an array of them. We know how big the array is to start with, so it should be easy to generate this array. So let's go ahead and start this. Public static int. We're going to return an array. First num self divisors int. fix this again. Let's put the Notepad Plus back in there. There we are. Okay, so make that a bit smaller. Okay, there we go. So we got an int start and int num. So generate a list of self-divisors. Okay, so the first part is very easy. We can make that list straight away. I'm going to call this divs, int divs equals new int, and just put num in there. And we need to keep track of how many we've got so far. So let's make a count. Starting at 0, we're going to count how many divisors we've got. We also need to track which number we're looking at right now. We're going to start at the start, but we can't use that. We can't use this variable. We have to keep track of it. So we're going to use a current, maybe a CUR for current, and I'm going to start that off at start. Okay. Okay. I think what we will probably need again is a while loop to keep going and going until we find the count. So while count is less than num, we're going to keep going until we get the right number of divisors that we need. And so what we'll need to do is have a test of whether the number is a self-divisor. If not, we'll keep going. So let's see if is self-divisor, and we're going to test this number, current number. If it is a self-divisor, then let's add it to the array. So let's divs, and we can use count as our index because it coincides with the number of things that we found. So it's going to start at 0, divs count equals current. Now we'll need to also increment count, because once we found one, we need to tick it up, right? So go from 0 to 1, 1 to 2. So we're going to add it there. You don't have to add it there. You can add it in the second line if you want, but I'm just doing it here so that it will add it after it's finished this line. It will add count, and that makes it just very easy. The reason I don't do it for current is because whether or not this is true or not, we'll still need to increase later on. So I don't want to do it again. So I'll just do current plus plus here. Right. So it tests the current number, see if it's a self-divisor. If it is, then we'll add it to the list. Right. Whether or not it is or not, we'll add it here. All right, and I think we need to make sure we return it afterwards. So return divs at the end. Okay. So 2 quite easy methods to write, not very complicated, only a few lines, but everything should be quite orderly and laid out like this. If you have something different, please comment, or I'll probably see your answers online anyway. But like I said, don't overcomplicate the questions. They are quite simple questions. I'm not really asking you to do a lot except just to maintain a loop and make sure that you're initializing things properly, running a loop properly. That's all you really need to do. Okay, stay tuned. I'll upload a separate video for the next question.